Hi, can you hear me? Yes. It's 1 after 5:50, and I guess we may have to start, or do we have to wait for some more minutes? Um, Probably, yeah. We have to start. Okay. Um, um, those of you who attend the conference online, please turn on the Zoom screen if possible. Um, it will be more convenient for you guys and also for the presenters. Um, okay. Good afternoon. This is Dr. Jinan Yu, professor of the Department of Education at KNUE, and I will serve as the chair of session 1, track 2, live oral presentations. Before starting the session, we'd like to thank all the attendees, domestic or overseas. In this session, we have a total of 3 presenters, and each presenter is assigned 15 minutes for presentation, and at the end of session, we'll have about 15 minutes Q&A. So if you have any questions or comments, you may wait until the Q&A at the end of session, or you may leave your messages using the Zoom chat menu. You can find the chat menu in the Zoom status bar. Okay, so the first presenter is going to be Miss Sujin Kim, and there are 1, 2, 3, 4, 5, yeah, a total of 5 authors, including Miss Bosun Min, Mr. Hyojun Yang, and Mr. Chani Lee, and Miss Sujin Kim. All of them are doctoral students at in KNUE, and the last author is Professor Kwang-sun Jung. Okay, let's upload Miss Sujin Kim, and let me hand it over to her. I think you are on mute.
Oh, good evening. It's a great privilege and pleasure to be with you this evening to discuss our research on integrated subjects textbooks in Korea. We are doctoral students in Dr. Chung Kwang-sun's lab, which has been leading the integrated curriculum research and national textbook publication in Korea. So we are also the co-researchers and co-authors of 2022 revised Korean National Curriculum and Integrated Subjects textbooks for elementary schools. I'd like to introduce our research team members. Would you like to wave your hands? We are Bosun Min and Chani Lee, Hyojun Yang. I'm Sujin Kim, and our supervisor is Dr. Chung Kwang-sun. So I'm sorry. Excuse me. So we'd like to start our presentation with the prompts, which is also the title of our research. Do textbooks influence the change of classroom level curriculum implementation culture? And we are focusing on integrated subjects in Korean elementary schools. I will be presenting our research in the following manner. First, we are going to see the outline, and then second, we'll describe the emergence and change of integrated subject textbooks. Then we'll trace the change of curriculum implementation culture, and then conclusions will be made. First outline. So we've started our study with the questions as a starting point. How did the integrated subjects textbooks manage to endure until now? And the second question was, what has been its impact on school education for the last 50 years in Korea? So we've conducted a qualitative meta-study. We've reviewed and synthesized the literature related with integrated curriculum and integrated subjects textbooks with the research question number 1. In the context of elementary education in South Korea, how has the integrated curriculum emerged in response to certain demands? And research question number 2, how has the integrated curriculum mediated the transformation of culture of curriculum implementation in South Korean elementary schools? Then let me describe the emergence and change of integrated subjects textbooks in Korea. We've distinguished into two subjects periods as school subject textbooks period and subject textbooks periods. And then we'll present our metaphors for each of them. School subject textbooks period. This period means cross-curricular and single textbook system. Discipline life, intelligent life, pleasant life, which are 바른 생활, 슬기로운 생활, 즐거운 생활, emerged in the fourth national curriculum revision. It is the first integrated subject textbooks appeared in the Korean educational history, and it started as school subjects. The subjects were divided into perspective school subject textbooks. So 8 subjects such as ethics, language, math, science, social studies, music, arts, and physical education from the third national curriculum were integrated into textbooks with distinctive subject curricula remained. And you can see the example textbooks in the picture. Then school subject textbook period. 바른 생활, discipline life. So it's the same school subject textbook period. Excuse me. So it's called multi-subject single textbook system, and you can see the example pages of different disciplinary area. It's science, math, and arithmetic. Let's see what the school subject textbook did in Korean education history. So there were the societal demand for alleviating students' burden for learning in that period. So the government tried to reduce number of textbooks from 8 textbooks to 3 textbooks that are enabling students to feel less pressured. And the individual subjects were converted into integrated school subjects. So you can see the example of change of the timetables in the first grade classroom. Practically, the number of periods are same, but the government aimed that students would feel the pressure be alleviated by presenting the subjects with a reduced number of textbooks and subjects. And then there is subject textbooks period. We had textbooks for monthly subjects for learning, which were through 2009 through 2015, it appeared with the 2009 revised national curriculum. They can be described as subject-centered, transdisciplinary, integrated textbooks. You can see the example subjects such as me, spring, family, and summer. The subject textbooks centered on a single subject, integrate the school subjects of discipline life, intelligent life, and pleasant life, and their respective curricula, and they were converted into one subject textbooks. So we had the monthly subjects for learning and subjects, it's called subject-centered transdisciplinary integrated textbooks. The example pages are here. This is the book for the first semester of 2nd grade. You can see the different lessons are designed to explore the subjects. So the first pages are showing that students sharing experiences about the subject, and the second page is showing the reading periods for a picture book related with a subject. And then the third pages are sequencing pages that are providing the selecting and organization opportunities for class. And the fourth pages are lesson plans with the specific activities. And let's see what the subject textbooks did. So there were educational and societal demands that the practice in classroom should change from teaching school subject textbooks as separate school subjects. Teachers tend to teach discipline life, 바른 생활, and intelligent life, 슬기로운 생활, and pleasant life, 즐거운 생활, as traditional school subjects, such as math, language, or sciences. So there were kind of voices raised to recognize this phenomenon as an issue. So the subject textbooks try to establish the culture and the landscape in the classroom where subjects or topics or students' interests can take the front view and the discipline take the back view of the landscape. It doesn't mean disciplines can be neglected, but it challenges the traditional way of setting foreground and background in the classroom. And you can see the example of the change of timetables in the first grade classroom. So the language, math, those disciplined subjects are remained, but you can see the topic as summer as the title of the subject textbook take the big primary time in the timetable. And we'd like to metaphorically describe the two separate ways of integrate textbooks we've reviewed. So for school subject textbooks, we'd like to say it as 한상 차림, a full table set menu. You can pick one or two dishes as you wish from the table, even though you eat all the food together. So you can taste the original taste of the distinctive dishes. And then for this subject textbooks, it's called 한 그릇 음식. It's a full dish, which is a final product with cooked various ingredients. So you can take the ingredients all together, but in a different way. So finally, you can eat the same diverse ingredients, but the way of tasting the food is different. Let's see the change of curriculum and integration culture. So we'd like to see the concurrent efforts for classroom reform movements. Traditionally, we had the lessons dominated with disciplined specific lessons, and then school subject textbooks appeared, which are presenting examples of lessons of integrated subjects. And there was a classroom reform movement, which were governmentally initiated. Then the widespread initiative for overcoming textbook confined and discipline specific lessons. So both concurrent efforts led the discipline-based lessons and integration lessons can coexist in the culture of classroom. Then second, the concurrent efforts for curriculum reconstruction. Another aspect is that there was a practice of integration in classroom, and then there was a widespread proliferated among teachers curriculum reconstruction movement, and it was school initiated. Then subject textbooks emerged, and the concurrent efforts together, they functioned as in-service teacher education. And these concurrent efforts together finally led the classroom curriculum development culture. So the curriculum reconstruction movement tried to develop local curricula responding to students' needs and interests. The subject textbooks, as we reviewed, providing a framework for integrated curriculum development with transdisciplinary subjects for teachers. And here is another metaphor we'd like to give. It's a 4-character idiom in Korean, 출탁동시. It means for a chick to emerge from its egg. Both the mother hen and the newborn must peck at the shell simultaneously from inside and outside, all together. And once Larry Cuban, who is an American scholar, once said, the success of school change and improvement hinges upon the effective coordination between the internal workings of the school and external influences. So these metaphors convey the importance of simultaneous culture formation from inside and outside of schools. With these conclusions, I'd like to draw our presentation to a close. As we reviewed, the integrated subject textbooks as national textbooks had influence on classroom level curriculum implementation culture. In that way, first, the utilization of the integrated subjects textbooks has afforded Korean elementary school teachers to experience in teaching lessons with integrated subjects and making lessons that integrate subjects centering on themes, which are subjects. And second, those experience of teachers have contributed the cultivation of the culture of classroom level curriculum development from textbook confined lessons with its concurrent efforts of school education change movement in Korea. So we've reviewed the emergence, change, and the influence of integrated textbooks and concurrent efforts of classroom level curriculum development culture. And we'd like to conclude that textbooks do influence on the change of classroom level curriculum implementation culture. Thank you.
Oh, thank you. Thank you, Miss Kim. And if you have any questions, you can ask in a very short time, or we can wait until the end at the Q&A session. Or as I mentioned, you may leave your messages at the Zoom status at the Zoom chat menu in the bottom of the Zoom status bar. Okay, so if you don't have any question, and if you don't have any questions, then we may proceed to the second presentation. The second presentation is from Israel. Dr. Noah Dana Picard, and also Dr. Sarah Hershkovitz.
Hershkovitz.
Hershkovitz, okay. Great. So are you in Israel currently?
Yes, really. Yes. What you can see is a nice view from Jerusalem, not from my window.
Wow.
Yeah.
It's so I'm so glad to see you here because isn't
Thank you
it
very much.
a very difficult time, especially in
Yeah.
Israel?
Yes, it's a very difficult time. That's true, and therefore maybe I have to say that as everybody knows that we are at war now, and a lot of people are there, and so it was not a trivial issue to be here with you now, and I hope that it will not happen. But if there is an alarm, I will have to leave immediately in order to go to a shelter. But I hope that it will not happen.
Yeah, we really appreciate your participation in the midst of a very difficult time in Israel. And let me
Thank you.
yeah, let me
I'm
briefly
very happy to be
introduce
with
you.
you.
Oh, the same. Yeah. Dr. Dana Picard has been involved for more than 30 years in teacher training, both pre-service and in-service. He has served as head of the mathematics department in different teacher training colleges, including Jerusalem College of Technology. And since 2013, he is president emeritus of JCT and director of a research chair. And he has authored or co-authored tens of research papers and book chapters. And most of his research is devoted to mathematics education, and STEAM education. And the other author, Dr. Sarah Hershkovitz, is also retired from the Center for Educational Technology in Israel. She published books and research papers in the field of problem solving, mathematics education, and STEAM education. And until recently, she was the head of the mathematics department at Levinsky Wingate Academic College in Tel Aviv. Okay, let me hand it over to Dr. Dana Picard.
Okay.
Thank
you very much. Yes. Thank you very much. I'm very, very happy to be with you, and thank you for the invitation. My colleague, Sarah Hershkovitz, cannot be with us. You understand that nothing works the way it should, but okay, nothing problematic, but okay, she could not be here. Let me share the screen. And here it is. I hope that you see the presentation. Okay, well, of course, the view you have over there in the upper left corner, it's not Jerusalem, it's your place. But where I had a nice opportunity to visit a couple of years ago when ICME was there, but a long time ago. So I have to speak about pre-service teachers in a technology-rich environment, learning to do in mathematics. As you will see, there will some general nonsense at the beginning, and then I will relate to a course that we developed last year with Sarah Hershkovitz also. And actually, what we have is that what we are doing in teaching mathematics and in educating pre-service teachers is actually an evolutive process. During decades, mathematics had been told according to a very specific scheme, definition, and theorem, and proof, and examples. But during the last decades, things has changed. And there's a big influence on these changes was the development of various technologies, and mathematics education saw profound changes. And if in the past, the changes occurred at large time intervals, from the second half of the 20th century, important changes became more frequent. And then the change is almost continuous. And what we propose here is a follow-up on our reflections that presented in this conference, this ICAS conference, during the 2 last years. And we will see examples with STEAM examples. STEAM, for people who are not familiar with that, is an acrostic for science, technology, engineering, arts, and mathematics, and actually looking at the world as a whole and not at separate domains. The STEM without the A was already well known, and A for arts entered during the last years, and so it can be related to architecture and music and so on. We have not enough time here to do it, so the examples will be limited to what we will show you. as an example of a revolution that occurred a long time ago, and it's mentioned by Trouche in one of his papers, and by Lavoie in his PhD thesis, is that when people passed from writing with a feather to writing with an iron quill, it was much easier to write. And as it was much easier to write, some things could, some tasks could pass from the brain to the hand. And so instead of mental computations, it was possible to do it on the paper, on a blackboard, and so the brain has been freed for new tasks. And so the mental computations went to writing, and so the brain was freed for this new task. And actually, that's what we can experience when we are looking at what happened from about the end of the 1960s to nowadays. And then the electronic devices which appeared at the beginning was only working numerically, and if you remember, but most of them are too young to remember these kind of devices. Even the computations was quite long. We could see on the screen what was happening, and that the CPU, it wasn't the CPU, but that the technology was computing. We could see, and more advanced devices have been developed, and more advanced algorithms have been developed. And so at the beginning everything was numerical, but now already 30, 40 years, symbolic algorithms have been developed. And then the packages called computer algebra systems and dynamic geometry systems have been developed. At the beginning, these were two different kinds of software. Now this distinction is not so clear, and actually all these big packages began to be multi-purpose. And besides that, other kind of software have been developed, theorem provers, and also algorithm for automated reasoning. And all this is not aimed at freeing totally from thinking, but to push people to another kind of thinking, to have other tools in order to push toward more understanding and more critical thinking in what happens. Not only applying, maybe there are still teachers who are applying technical work. If you want to do something, you have to do so and so. But as educators, I think that we have to push people to understand more. And even for all these algorithms and all these devices, they are a good incitement to try and understand more. And here, for example, we could use these tools for automated reasoning in order to find geometric loci. This is a very old question. It's a classical question in geometry, and these automated reasoning tools, ART, can be used in order to solve new problems and to discover. This is the important word, to discover new properties. They can be used in order to explore classical theorems, but it enables the user to discover new theorems. And this is only a part of the tools which appear for us. On the right, what you have, it is an example of a screenshot for a discovery in plane geometry. And on the left, it's a connection between curve in plane and curves in space, and parametric curves, also using the development of this automated reasoning. And what we have here on the left is a model of the movement of a satellite around the planet, around the sun. So it's possible to do it very, very easily and very early in the development of the mathematical knowledge of the students. And these are only a few examples of a stream approach where we can mix all kinds of knowledge. If mathematics were classically taught separately and every domain was taught separately, now we have a possibility of an approach, an integrating approach, and this STEAM approach appealing to the knowledge of the students, the cultural background of the students, and their specific skills. Some of them are more art-oriented or more chemistry oriented or more physics oriented, but it can have a very big appeal. For example, with all what happens today in space, with all these satellites and probes and exploration, people have a good incitement to develop this kind of model, and they can be done quite early. And all this works within a general frame, which is called the 4 C's of 21st century learning. This has been defined a couple of years ago. You have here some kind of description, what every component of these 4 C's are proposing to you. And actually implementing this kind of activities that we propose, we can appeal to the different components of the critical thinking and collaboration and creativity and communication. And of course, collaboration and communication, we can understand it. I will relate to that a little later. And all this, to define creativity, it's not really easy. There are some trials to define what creativity can be. And the critical thinking is that we can understand that not receiving anything. And for example, what you are hearing from the newspapers or from radio, TV, and so on, we have to exert critical thinking, because generally people can, on the same photo, tell very, very different things. One can be true and the other a lie. Everything can be a lie. And so it's very, very important. And to teach, to educate people to critical thinking of what they receive is very, very important. And if I said before that to use a cultural background in order to incite people to learn mathematics, actually, if we are explaining, educating them for this, for example, critical thinking, they can go back to their everyday life and to exert this critical thinking to everything, not only in mathematics. So this theme, education, is really important for everything that we can do. And the problem can be that the STEAM approach faces several difficulties. One of them is an insufficient background in non-mathematical domains, both as teachers and students. If I said that we could use what they hear in the media about space exploration and then to bring them to develop mathematical models to see how these probes are behaving in space, why it's not possible to send a probe directly from the Earth to Mars on a straight line, and it has to be curved, and which kind of curve do we have? Many people don't know that, and so we can explain that, and we can develop models for them, and then people will have in their everyday life more understanding of what happens. And it's true for this exotic example, but it's true for something else. And so the first step to solve the problem of insufficient background relies at the beginning in teacher training. And so teachers, Sarah always say that people teach the way they have been taught. So if you educate the pre-service teachers to integrate different domains, they will do it in classroom after that. But how to do that? The course that we developed last year was aimed at pre-service teachers in a college, in the training college in Tel Aviv area. And so the students' population was inhomogeneous. It was a decision of the administration of this college. And so the inhomogeneity was because of they had different mathematical background. Some of them had a strong background, some of them didn't have. The general knowledge that they have of what happens in the world and their technology literacy. Some of them knew already how to use the software, in this case, GeoGebra. Some of them had some knowledge, and many of them didn't know even that it exists. And so they had to have even a very elementary introduction to that before we could arrive to mathematics education. So it's really an endeavor for the educators, but it's an incitement both for the educators and for the institution, and of course for the students to create new frames and new tasks, not the classical one. And then the difficulties were that creativity is a main word. And sometimes students are taught to imitate what the teacher does. We didn't want that. We wanted them to be creative. And so I could present something, Sarah could present something, but we wanted students to be, to take initiative, to be innovative, and to be able to do that. And so we had, even for the same topic, to propose different tasks in order for the student to develop a new understanding of these notions. And for example, in linear algebra, some of the students didn't learn the preliminary course in linear algebra. So something about plane transformation, rotations, reflections, and so on, they didn't have. And so we had to explain that. But in that case, the usage of the software was very, very important in order for them to imagine immediately what happens, and what is a rotation, and what is a reflection. And so they could do it. And so the theoretical knowledge appeared together with the technological skills. And actually, Artig said it, that the new technological knowledge is an integral part of the mathematical knowledge that the students are acquiring. And so the teacher has to explain basic notion, but some of the students knew already. And so slowly, they could go ahead. And for example, after one meeting, one of the students did something which was not proposed by the teacher, and came the 1 week after with a very nice dynamic model of a gyroscope. And so it happened a lot of time. A second example is exploration of curves. Students learn a course in calculus, and so they know how to check what happens with the function, and to draw it, to plot the graph, and know when the curve increases, decreases, and so on. But parametric curves are not always a part of such a calculus course. Even in an advanced calculus course, it's not so present. So something had to be done. And when working with parametric curves, we could obtain very, very strange curves. This is also connected to models of trajectories in space. And the curves that had been obtained presented sometimes symmetries, rotational symmetries of the order 7, 9, 11, something where generally by hand is not done. And when we are presenting symmetry in a plane, generally it's a reflection of the rotational symmetry of order 2, order 4, but 7, 9, 11, 13, it's generally non-existent. It cannot be explored. And here, using the software, we could use that. And you have here two examples. One was totally abstract, the example that you have, that you have in the middle. But the other one that you have on the right could be very, very dynamic, using the slider bars and the various possibilities to animate the graphs in order to construct. And this is even a more abstract presentation of something coming from a previous exploration of a space trajectory. And so we could do all this. And finally, what I should emphasize, and it was very important, both for work in classroom and for remote work, because part of the course was delivered in class in a synchronous way, and part of the course online in a synchronous way, and part of the course in an asynchronous way. But all this communication and this collaboration could occur not only between humans, as generally people understand, but it's also communication between humans and machines, and between machines, because we could do it not in this course, but in other course, to use two kinds of softwares, and we had them, we have the need for them to collaborate, because the strength of one kind of software can be different from the strength of the another one. And for example, using GeoGebra and in parallel Maple could use the huge possibilities of algebraic computations in Maple, which is much stronger than in GeoGebra, but the way how to say, the way GeoGebra works and for animations is a little more user-friendly, and working with both was very, very important. And this enabled us to develop both classroom activities and extra classroom activities, and to use a true STEAM approach, using examples coming from architecture and biology and space and so on, really a true STEAM approach. The components were very different. And finally, what I should say is that the OECD presents these 4 C's of 21st century education, but actually we want to add a 5th one, which is very, very important, is also curiosity. We have to incite our students to look at new things, to be very curious, to discover new things, to explore. And if we add this, I think that we will have the 5 C's of 21st century education. Thank you very much.
Oh, wow. Thank you. Thank you so much for your presentation. Actually, I have a master's in statistics, and I had to take a linear algebra, a graduate level course during my master's in statistics. And I wish I could have the opportunity. I could have had the opportunity to use the technology that you mentioned. It would have been much easier or smoother. Okay. Yeah.
For sure.
Okay.
For sure.
But it's all gone, and I don't have to learn linear algebra anymore.
Yeah.
It's okay.
You know, a colleague of mine told for in-service teachers in one of the sessions, she said, her name is Norit Zehavi. It's probably 20 years ago already. She said that we are trying to use all this kind of software, not GeoGebra, because GeoGebra has been invented and is developed for educational purposes. But the other big packages, such as Maple and Mathematica and so on, she said like that. All these packages have been developed in order to free people from thinking. But we are using that exactly to attracting people to think more and more profoundly.
Yes, I cannot agree with you more. Okay. Thank you again, and let's move on to the last presenter. He's from Hong Kong.
Yes.
Dr. Win Kin Cheng.
Yes.
He's from
If
the
we
Chinese
excuse me, but I will have to leave.
Oh,
Life is very strange these days, and so we have so many duties, also helping other people. So I'm really apologize, but I have to leave. I hope that everything is recorded and I could see that later.
Oh, okay. Yeah, we all understand that. Then can you have some minutes for Q&A
Yes.
before you leave? Okay, great. Then and do you have any questions or comments to Dr. Dana Pickard, because he has to leave, and we have some minutes for Q&A.
Okay. Sorry for the trouble.
Oh, we totally understand it. It's a very, very difficult time in Israel, and
Yeah.
I'm very surprised to know that you actually made it.
Yeah.
Any questions or comments to Dr. Dana Pickard?
Okay. It's
Okay.
that I am not. So I hope that we will meet again, maybe for once face to face in a more peaceful time.
Sure. Yeah. It will happen soon.
Yeah, I
hope.
hope so.
Okay, then thank you.
So
Thank you very much.
have a good time in Korea.
The same in Israel. Okay.
Thank
Bye.
you. Bye-bye.
Mhm. Okay. Let me introduce Dr. Win Kin Chen. Dr. Win Kin Chen received the Doctor of Education from the University of Hong Kong, and his research interests include STEAM education, mathematics education, learner agency, and learning as making. Okay, Dr. Cheng, you may share your slides and proceed, please.
So hello, can you hear me?
Yes.
Okay. Wait for a while. Okay, I have just sent some file to you on the chat. Okay. Now I'm going to present to you about some creative problem tasks in a creative problem competition in Hong Kong. Okay. The problems in this presentation are extracted from the Hong Kong Mathematic Creative Problem Solving Competition for secondary school in the last years. And these competition, the student, they form teams of 4, all of them are from secondary 1 or secondary 2. And that means they are grade 7 and grade 9 students. And each school can only send one team to participate the competition. And in the final, they have some interesting tasks to solve. So let me introduce to you about the task. So our student asked to use A4 size paper, so one piece of A4 size paper, and then finally they need to make some container, open container. They are required to test the container with some beans, and then estimate and calculate the volume of the capacity of the container. And the student, they are given A4 size paper, scissor, and adhesive tape.
Sorry, Dr. Chang, but I don't see the slides changing.
You can't see it? Okay, so
Yes,
let me stop it and I use another one. So please wait.
maybe you can use the full screen because the screen that we saw were just the partial slides or
Okay, let me use this one, maybe this one.
okay, sure.
Okay, so can you see it?
Yeah, yes, great, yeah,
Okay.
no problem.
Okay, so on the task in the final rank, the student, they need to make container, an open container using A4 size paper. There are different tasks for them. Finally, they need to use some beans and then put the beans on into the container, and then they have to estimate and calculate the capacity of the open container that they made. And there are few tasks for them. So the first task, they need to make a container that has volume of 100 cm cube and 500 cm cube. And the second task is to follow some given template, and they need to make an open container. And they need to follow that template and then try to estimate the largest possible capacity of the container that they made. And the third problem was to make an open container with the largest possible capacity using only a piece of A4 size paper. They can cut the paper, they can use adhesive tape, and then they can stick the paper together and then form an open container. Okay, and the last problem, it was the most difficult task. They need to use only one 4-side paper without any adhesive tape, anything. They need to fold an open container so that they can hold something. Okay, so and now let's see how the student how they work. So for the first task, they need to design an open container whose volume or capacity is 100 cm cube and 500 cm cube. And here you can see that some students, they draw the net, and then they explain to us how these container can give the capacity of 100 cm cube and in 500 cm cube. And this one, I think it's not that difficult. Quite a lot of students, they can handle it. And then the second task is that we have a template for them. So we ask the student follow this template. This is an A4 size paper, and then they need to fold it. And the length of A1, A2, this size, we do not give them. They need to check, they need to test, and they need to find the largest possible volume or the capacity that they can make with this template. Okay, so these are some instruction with this A4 size paper, and they can fold it like that. Okay, and and here some result from our students. You can see some of them. They model this situation. They set some function and set some variable, and then they test it with the idea of calculus, and then they can estimate that the largest volume, the length of the size of the paper should be 4.04, and they have this result, and they can get the largest possible area if the length of this size it is 4 cm. Okay, so it is quite advanced. So can you see it? The grade 7 and grade 9 student, they are using some calculus concept, and they try to solve the problem, and they can estimate the largest possible capacity of an open container. And the next one, this one, it is the task that the student, they can only use one A4 size paper, They can cut it, they can stick the different cutout, and then form another container, that an open container that can hold the something with largest volume. And you can see all these are some student work. Some make cubes, some make different container of different shapes. Okay, and it is interesting that we can see the creativity from students. They can have lots of different idea, and what they did is they make this container, and then they try to estimate the volume of this container. Some of them they can calculate them. Some of them they use the basic one, the original one. That one they pour some beans into this basic container, and then they try to estimate the volume of the open container that they made. Okay, so this one is quite interesting. And we also we are in the judging panel. We also try to there are different teachers in the judging panel. When we design this task, we also asked some teachers and asked if they can give us some good idea about how they can make the open container. So this is one of the design. So an A4 size paper, and we can cut along the solid line, and then fold it up, and then this rectangle we can put it to the other side, and then fold it up, and then we can make a cubebot like that. Okay, and we have another solution. So this solution actually, if you look at it, it is in the shape of some Rhombi cuboid hexahedron. Okay, so actually this design it is inspired by some model that we made from 4D frame. So if you look at this one, it is Rhombi cuboid hexahedron, and when we use the A4 size paper to make this one, we have lots of different square and equilateral triangle. But for an A4 size paper, we cannot make the whole one, and we can just cut some rectangular shape, and then we put it as the size of this container. You can just look at this one. So if you look at this one, it looks like a hemisphere. So so the volume would be maximized if we can make a hemisphere for making the open container. And we have another design again. This design is also inspired by some model that we use the 4D frame to create it. So we make a simple inverted frustum using 4D frame material. And after that, we try to figure out how we can use an A4 size paper to design it. So and in order to maximize it, the teachers find out that if we use the base as 9 cm as the size, and the top square we use 12 cm as the size, then we can maximize the length of the A4 size paper. And we have these paper left behind, and we cut it out and then we stick it to the sign and we form a larger one. So we have another open container here. Okay, so now we have the last task. The last task is the most difficult one. The last task is that the student need to use only one A4 size paper. And they cannot use any other material. They cannot use scissors. They cannot cut them out. They cannot use any adhesive tape to stick them together. Okay, so this part, it is the most difficult one, and quite a lot of students, they cannot make it. They failed in this task. But let's see how we come up with different solution as the judging panel. So the first solution that we come up is like this one. I guess that you might see this. This is just something. Use some paper, and we make some Chinese paper go angle. Okay, so we use some technique to fold it, and then we can fold this kind of shapes. And with one A4 size paper, what we do is, first of all, we fold a symmetrical pipe, and at the end here, we fold it a few more times so that the paper lock them together. And then at one end, we also use the technique in making some Chinese paper golden eagle. Then again, we fold it, and we have some interlocking part so that it becomes much firmer than the original one. So we tested it, we pour some bean into it, it won't collapse. And here we have another design. Actually, this design it is amended by our judging panel after we see student work. So we make something look like a boat, and then we have this dotted line. So if you fold along this dotted line, you don't cut it. And then you can fold it, and then you can have some part that you can fold it up to inside, and it can lock the other part. And so when we pour some beans into it, it won't collapse. And then we have our final solutions. This one is even much stronger. So if we use the original design that we give student, and we fold another line here, and you can see it after folding like that. Then we have a certain part here, we can fold it outward, and then this part, it lock the corner. So it is really interesting. You can try it out. So without using any tape, you can make a container like this. It is open cuboid, and you can hold quite something with weight. Okay, but this task, most students, they fail in this task. Okay, so these are the tasks that we give students, and we discover that there are some area that students they can improve on. We find out that many students, they have excellent computation skill, and some of them, they have advanced math knowledge. However, they lack some problem solving skill, particularly when they do some hands-on tasks, they failed on some hands-on tasks. And students, they are generally weak on hands-on tasks, and we discover that some students, they could not even use some simple tools competently. So some students, when they use scissor and they use adhesive tape, they take very long time to stick something, just like stick two paper together, and it is they do not use them quite competently. And some students, they were good in the question with clear procedures given to them. They can follow the procedure, they can do lots of calculation, but they are weak in creating something new, just like our last problem. If you ask them to create something new, they failed in this part. Okay. And here, let me explain to you the palm making. So in all these tasks, and we find out that every time when a judging panel, when we met, we discuss, and every time after discussion we have something new, and then we go back home and then we try again, and we make a new model. And sometimes we even try to beat another one's solution. So someone make a container whose volume is say 1000 cm cube, and the other one, the next time they want to try to make another one that can beat you. Okay, so you can find that this kind of tasks are really inspiring. And another thing, I noticed that 4D frame, it is really an excellent tool to help us.
Sorry to interrupt, Dr. Cheng. We have another session, last session. So please, can you wrap up?
Okay, so the final things, so 4D frame is a good tool that we should use, and also I would suggest that we use more 4D frame, and also we design something that we may use the technique of origami. Okay, so that's it for my presentation. Thank you.
Thank you very much. Okay, to me, the tasks that you explained are much more difficult than the linear algebra from the previous presentation. I actually have some questions before before others, and so are the students' ages from 12 to 14? You said that second.
Yeah, 12 to 14. Yeah.
So okay, and were there any gender differences, males between
No,
males and
boys and girls, they can join the competition. Yeah.
so how many students were there? Did you
They're
conduct
all
any
together,
statistical tests?
they're all together 8 teams in the final, and each team have at most 4 students. Some have 3, some have 4. So altogether, there are 20-something students in the final.
Okay.
Yeah.
Final. So there are the students are not the number of students is not really big to conduct any statistical tests.
No, not really, not lots of students. They go through the preliminary rank, and then they 8 teams, they enter into the final, and they have these tasks, and they try to solve these problems.
Okay. The reason that I asked about the gender difference is that because I think there might be some differences in the hand dexterity. So although the students are their brain can function. I mean to do the tasks, but their hands are not really good enough, and because they have to cut and fold the A4 paper, right? And
Yeah.
so did you provide any help doing the hands-on experiences?
I think the student, some boys, some girls, they are not really very good in using tools, even scissors and adhesive tape. I think it is not about the gender difference. I think it's about our education. So very often we have lots of exercise for the student, and they lack some hands-on tasks. So I would suggest that it would be better that if we incorporate some hands-on tasks during our teaching to the students.
Okay, so it's just my boy. He's not really good. Okay, and we have a comment in the Zoom chat menu. Could you share insights on how the judging panel evaluated the effectiveness and creativity of the different container designs? Can you explain
Okay.
that?
We have different criteria. Some criteria is just like the accuracy of the calculation. So can they have some accurate calculation? And if they do not have some formula to calculate it, do they have some good way in estimating it? Just like the first task, they need to design some container that can hold 100 cm cube and 500 cm cube. If some groups, they can use those container and they use the bean and then pour it and then put it in the container that they made. And they can use those as reference to compare the volume. And in that case, they would have high score. And also for the design, if they are creative, they can make something that is insightful, then we would give them high score.
Oh, thank you. So, Hyunshik Ju, do you have any further questions? Okay, then I think we may have to action, but I thought it ends at 7 p.m. in KST. So I thought we have some more time for Q&A, but am I? Okay, then do you have any I think we have only one more question. He can answer one more question if you have any question or comments, or otherwise we may have to move on to the roundtable session. No, anybody else? Okay, then okay. Okay, then thank you very much. Thank you very much, Dr. Chang. It was very interesting, and the last session 3 will resume in 7 minutes which is 7 p.m. in KST or 11 a.m. in CET. So you may visit the roundtable session using the link in the chat menu there, in the Zoom chat menu. Okay, then let's all say goodbye here and have a great evening, the remaining evening. And I hope that you will have a great time learning and meeting all of those people from all the world. Okay, thank you, and see you again. Bye bye. Bye. I'm gonna leave.
대표님, 선생님들 링크 종료하겠습니다. 위 링크로 들어가 주세요.